To understand the interaction between soil and water, we need to talk about how soil holds onto water. It's a really cool process, and there are a couple of key ways it happens. I'll break it down for you in a simple way. First, imagine you've got soil with a layer in it that water can't get through, like a waterproof barrier. When water soaks into the soil, it hits that impermeable layer and starts to pile up, creating what we call a water table. If you keep adding water, that layer of soil above the barrier gets completely saturated, meaning there's no air left, just water. We call this waterlogged. This can happen all the time, or just for a little while, depending on the soil and the conditions. Now, the second way soil holds water is through something called capillarity, and this is where things get interesting. Capillarity is basically how soil, which is full of tiny pores, can suck up water and hold it even above the level of the water source. Like if you dip the edge of a sponge in water and it soaks up higher than the water level. The water moves into those pores and stays there, even if you take the water source away. This happens because of two forces working together: adhesion and cohesion. Adhesion is the attraction between the soil particles and the water molecules. Soil particles often have a negative charge, and water molecules are polar, so they stick to the soil like magnets. Cohesion, on the other hand, is the attraction between water molecules themselves. They like to stick together. So, adhesion pulls the water to the soil, and cohesion helps the water molecules tag along with each other, filling up the pores. Here's the cool part. Because of capillarity, water can stay in the soil even though gravity is trying to pull it down. But how tightly the soil holds, that water depends on how much water is already there. If the soil is pretty dry, the water is held really tightly, and it takes a lot of force, like a plant trying to suck it out, to get it out. But if the soil is already full of water, the water isn't held as strongly, and it can even move out on its own because of gravity. A classic way to picture capillarity is with a thin glass tube, called a capillary tube. If you stick one end in water, the water will climb up the tube higher than the water level outside. That's because the water molecules are attracted to the sides of the tube, adhesion, and they pull each other up along the way, cohesion. It forms a little column of water inside the tube, but there's a limit to how high the water can go. The cohesion between water molecules can only hold so much weight. Imagine the water molecules at the top of the column are like, "We can't pull up any more, friends." When the weight of the water column balances out with the cohesion forces, the water stops rising. That's when everything reaches an equilibrium. So, that's the gist of how capillarity works in soil. Pretty neat, right? Have any of you seen something like this in action? Maybe with plants or in a garden? Let's hear your thoughts.